Hi. Hello, hello. Let me know if you guys are here. Hi. Hey, Sergio. Hey. I did. I said hi to you already. Hi, Angela. Hey, Grace. Hey. Okay, let me try. Let's see. And he. I'm so sorry. Let's see. Hi. Thank you, Banana Kid 111. Thank you. Okay, so last time, as you guys probably know, my live stream didn't do so well because, yeah, the internet issue and things like that. And hopefully today it's actually better. And in the meantime, let me try to clean my lens actually. Okay. And seriously, I only have a cell phone like an iPhone 6. That's what I'm using to record. Okay. And there was a request that I need to show my shoes, so I'm going to show some of the viewers' shoes. So I'll show you guys this pair right here. I mean, this shoe right here. But anyway, get back to math. Okay, so I think the first like 2-3 minutes or so, I will just say hi to you guys, and then this is where I can wait for people to come in. And for the people who know here, for the people, thank you. And for the people who are here, and if you guys know any like high school students who are taking the AP Calculus exam in like 2 months or so, I will try to make this into a regular thing, and I will be posting like regular schedules for you guys and things like that. And if you guys want to try these questions, the link to the file is in the description, so you guys can download download the problem and work on it on your own. And if you want to try it right now, you can go ahead and do so as well. Thank you. All right, so as I said, I will be waiting until the 3 minute mark and then I'll start. Some of this right here is still BC suitable, Grace. So hopefully you still find this to be helpful. But for the streaming right here, I will be just kind of go over these questions in a tiny manner. And on average, you pretty much have about like a 2-3 minutes on the AP questions, on the AP test per question. So we will have to work this quickly as well. For the challenging questions, I think I'll just make them into my regular videos. I think that was the feedback that I got from my subscribers. So I will do the live streams like this for now, and we'll see what we can do later on. It's about like 45 minutes per section, and each section I think has like about 15, 20 something questions. I forgot. Okay, I think there was some like small issue earlier, but hopefully everything's okay now. All right. Okay, so anyway, let me just work through number one with you guys. And is there anybody who knows the answer already? In fact, I did this last time already, and then yeah. Hey, welcome back. Thank you. Yeah, unfortunately, I don't know, like the app just jumped out earlier, and then like I had to come back, and yeah. Cool. All right, anyway, let me just work this out for you guys. So we will be doing implicit differentiation for these 5 questions for today. We're given this equation and we're trying to find out the value for dy dx at x is equal to 1. So I will just go ahead and ddx right here. We have to use implicit differentiation because the y is not isolated. Hi, Gustavo. And then right here, we'll just take the derivative of 3x squared with respect to x, and that's going to give us 6x. And then right here for the second term, we have to differentiate 2xy with respect to x. And we have to remember x and y are both functions of x. So right here, I will just put a dot in the middle because we have to use the product rule. And the version of the product rule I'm going to use is that I will keep the first function as how it is. So let me write down plus 2x. and I will differentiate the second function and the derivative of y, because y is a function of x, we will just get dy dx, okay? And this is how we can squeeze out the dy dx, the derivative of y with respect to x right here. And when to continue, we have to add the second function, which is the y right here, and then differentiate the first function. The derivative of 2x is 2, right? So we just multiply this by 2. Okay, and then for this term, we'll just add, bring the 2 to the front, right? And then minus 1, so we have 2y. And once again, in this case, we actually have to use the chain rule because the derivative of y is dy dx. So we multiply this by dy dx. And then this is equal to the derivative of 2 is 0, okay? And by the way, this question is from almost 50 years ago, back in 1969. Anyway, this is the expression that we have a derivative right here, and we are going to find out the value when x is equal to 1. But as you can see, it also involves the y value, right? So I will have to plug in 1 into the x right here to figure out the y value. So let's see what the y value is. I will just plug in, let's say when x is 1, we will have 3 times 1 square, and then we add it with 2. The x is 1 right here. And the y we don't know, and then plus y squared, and this is equal to 2. Just plugging 1 back into the original, right? And then from here, we can just work this out quickly. 1 squared is 1 times 3 is 3, plus 2 times 1 times y is just 2y, and this is plus y squared, and this is equal to 2. This is quadratic. I will move the 2 to the other side and then rearrange this. Let me put down y squared first, and then plus 2y. Minus 2 on both sides. 3 minus 2 is going to be plus 1, and this will be 0. Factor this, we get y plus 1 squared is equal to 0. And from here, we only have one solution, namely y is equal to negative 1. So from this, we can just plug in x is equal to 1 and y is equal to negative 1 into here and then solve it. So you can do that right now, or you can isolate the dy dx first and then plug in. Sometimes the AP questions will ask you to get the dy dx expression, so I will use this as a chance to show you guys how to do that just for practice. So right here, notice that we have these two terms involving the dy dx. I will keep them on the left hand side, and I will move the 6x and the 2y onto the other side. Right here, I will factor out the dy dx, and I'll put that at the end, okay? So it's going to look like, parentheses, we have the 2x here, plus 2y, and then times the dy dx. And that will be equal to, move the 6x to the other side, we get negative 6x. Move the 2y to the other side, we get minus 2y, okay? And then, the reason I put the dy dx at the end is that this looks similar to the ddx, but ddx means to take the derivative. This is the derivative already, okay? So I didn't want to put this in the front, otherwise it looks like we have to take the derivative again. But anyway, I will then isolate the dy dx by dividing this on both sides. So I get negative 6x minus 2y over 2x plus 2y. And now we can just plug in this right here, and we will see that dy dx, and I know I'm just showing you guys all the work, right? The actual test, you don't really have to show a lot of this work. As long as you are neat and you understand your own work and you can get the right answer, that will be good. Anyway, x is 1, and then okay, E, yes, cool. You just choose the best answer right here because, of course, when we have 0, we cannot evaluate this. And of course, you will also have a vertical tangent line at this point, but among all the answer choices, not defined is the best answer. Okay. All right. Unfortunately, I don't know too much physics, so yeah. Maybe we can ask Flamball Map to do some for us, but yeah, we'll see. Hey, Cici. Let's see. I'm just saying hi. Let's see. I can tell if it's a guy 10. Oh, okay. No, it's me. Okay. Let's see. What's Hi, thank you. Okay, cool. We'll continue. So I think after I finish the question, I will read you comments and then yeah, and yeah, we'll continue to the next one. Anyway, this one is from 1973, the AB version. Okay, but of course, if you're in BC, then you should know this already. But anyway, right here we're given that the equation is tangent of x times y is equal to x, and we're trying to find expression for dy dx. So once again, implicit differentiation in action. Derivative of tangent is secant square, and we will first keep the input to the same, right? And then we have to use the chain rule, and I'll use a blue pen for this right here. We are going to be differentiating the inside, but this is x times y, so we have to use the product rule. So I will multiply by, let's open a bracket. I will keep the first function, which is x, and then multiply by the derivative of the second. The derivative of y is dy dx, and then we will add the second function, which is y, times the derivative of the first function. The derivative of x with respect to x is just 1, okay? So this is it on the left-hand side, but we have this equal to x, right? So we have to say this is equal to the derivative of x, which is 1 now. And from here, we have to isolate the dy dx. And as you can see, we have this bracket with this in front, right? Therefore, let's distribute this. And let's write things down carefully and neatly, where x, y like this. And then right here, we will have to divide both sides by that. And you know what? I shouldn't distribute because I should have divide this on both sides. So never mind. Let's not do this. Because I noticed that this right here, it's not that nice. If I divide this on both sides, it's easier, right? So let's go ahead and do that. So right here, let's divide both sides by secant square xy, divide both sides by secant square xy. So this and that will cancel each other right away. And then I see that I will have x times dy dx, and then plus y. And this is going to be, well, this over that. 1 over secant is cosine, and 1 over secant square is cosine square. So this is cosine square xy. And now I will just do two steps in my head. First of all, minus the y on both sides, minus the y onto the right-hand side, and then divide by x. So this is going to be y dx equal to, I will keep the cosine square xy right here, and then I move the y to the other side by subtracting, so I will have the minus y. Once I have that, I will have to divide it by x on both sides. So I divide it by x on both sides. So in the end, this right here is the answer, which is answer choice E. Okay? So this right here will be the easier way. I shouldn't have distributed this earlier. Okay, can you guys see okay? All right, so this right here are the first two questions, and now we have the next three right here. Last time I only have the time to do the first one, and then my internet went off. That kind, like the Wi-Fi didn't work and all that stuff. I teach at a community college, and I used to teach with high school students. Yeah. And let's see what else do you guys. Okay, so for number 3, this is from 1997 AB. And I think some of my viewers, you guys are born in 1997. But anyway, given this equation, this is a circle with the radius 5, x squared plus y squared is equal to 25. And we're trying to find out the second derivative, okay, at the point 4, 3. So first of all, let me differentiate both sides with respect to x. And by the way, this is a pretty common implicit differentiation question, and it's kind of fun. All right, so this right here, derivative of x squared, give us 2x, and the derivative of y squared, well, we bring the power to the front, -1, just like that, so we get 2y first. But we have to differentiate y because y is a function of x. So we multiply this by dy dx. And then this is equal to the derivative of 25 is just 0. So this is pretty much it. And from here we know that dy dx, namely the first derivative, it's going to be, let me move this to the other side, which it will be negative 2x. And then once I isolate this, I will divide both sides by 2y. So I will divide by 2y like that. And of course, you can simplify this a little bit. You can say this is equal to, we'll cancel the 2's, of course, right? And then you get negative x over y. And now we have to get to the second derivative. Well, the second derivative is just the derivative of the first derivative. So I'll be looking at the first derivative right here, and then differentiate this again. Of course, I'm using my blue pen, like this. Okay, right here, this is how we can end up with the d2y dx2. And as you can see, the d happens twice. So that's why we have the d2, and then the y. And then on the bottom, we have the dx happens twice. So that's the dx2, okay? Right, now, we'll be looking at this. And this is negative x over y. And let me just use the quotient rule for the derivative right here. So I will I will draw a fraction bar. I will square the denominator. So I will get the y squared. And then I will bring the bottom function to the top, which is just y. And I will multiply by the derivative of the top function. Derivative of negative x is just negative 1. And then I will minus the top function, which is negative x. And then I will multiply by the derivative of the bottom. Derivative of y is dy dx. So this is what we have. However, though, this right here is dy dx. I will have to go back to my original dy dx and plug in negative x over y into here so that I can get an expression with just x and y. Okay, so let me do that. On the top, we have negative y, and this times that is positive, and then we have the x. And for the dy dx, I will multiply this by negative x over y, and then this is over y squared, like that. Okay, from here, we're pretty much done, and you can just plug in values if you would like, but in the end, you will have to, you end up with complex fractions. So let me just simplify this a little bit before we go on. Let me multiply the top and bottom by y, okay? Because this way, you will see y times negative y gives us negative y squared, and the x times negative x, this is minus x squared, and y cancel each other out. And then this is over y squared times y is y to the third power. And this is the second derivative, okay? So I will just, put this down right here. This is the d2y dx2. Okay, and now I will just plug in y, which is 3, right here. And then we'll do the square, and then this is minus 4 for x. And then square that over 3 to the third power on the bottom, like this. Work this out. On the top, we get negative 27, and then this is minus 16, and over positive 27. And let's see if I'm lucky enough to get the answer. So this is 27 minus 16. This is negative 43. Something is wrong. Let me see. 0, not 27. Why is that 0? Wait. Ah, yes, this is not 27. So the good thing about multiple choice is that if you don't see the answer right here, that means we did something wrong. Okay, 3 squared is 9. Okay, so it's supposed to be -9. Anyway, -9 minus 16, this is -25 over 27. This is good because I can ensure if you guys are watching or not, just like how I'm teaching an actual class. If I make a mistake, you'll see if you guys can catch it or not. Oh wow, you're watching it on the TV. That's so cool. Okay, cool. So anyway, well, if this is not live stream, right? Usually I'll be able to catch it and will edit the video. Or if I somehow post a video that has a mistake in it, then people will call me out anyway, right? Yeah. Okay, cool. So are we good so far? Let's see what time it is now. This is right now. Let me see. It's 4:20 something right now in LA. Well, some of the pertinent questions are really hard for me, so yeah. But anyway, let me just continue right here for this too. I'm sorry about the previous comment. But you have to make me. Oh, I'm glad. I like discrete math as well, but maybe I can do some like small questions for probabilities later on for like discrete math during live stream. But from now till May 15th, I would like to do live streams for AP questions. Okay. I will have to collect the questions first though, so that's the thing. Yeah, I have to come up with the probability questions for the counting questions. Those are the fun ones. Okay. For Duncan, I don't have a PhD in math. Okay, I only have a master degree. And let's see. Some of these are in BC as well. So this right here is BC. And in fact, I am going to do like a divergence test later on. Not today, but like maybe later today or something. I don't know, depends. Okay, so this is for Angela, yeah. Okay, so let's continue. We are given the first derivative. This is dy dx is square root of 1 minus y squared, and we are trying to get to the second derivative. And this is the BC version back in 1998, which is 20 years ago. Okay, so I will just be differentiating this ddx right here, okay? And I will get d2y dx2 right away. And now to differentiate square root of something, this is going to be 1 over 2 square root of the inside, and that's 1 minus y squared. And then because of the chain rule, I'm going to multiply by the derivative of the inside. Derivative of 1 is 0. Derivative of negative y squared gives us negative 2y. But since y is a function of x, I will have to multiply by the derivative of y, which is dy dx, like this. From here, we can simplify, right? And let's see. Actually, I have to charge my phone, so give me 1 second. Okay, so right here, let's see, I'm going to cancel all the 2's, and I'm going to plug in this in a second. This is going to be, we have negative y on the top, right? Negative y right here over square root of 1 minus y squared. And for dy dx, this is just the original that's given for the first derivative. So I multiply this by square root of 1 minus y squared. This and that cancel nicely. So in the end, this is nice enough to be negative y. And that's it. And answer choice B right here. Okay? Okay, and let's do the last question. I will try to keep this kind of live stream like within 30 minutes. So let's finish the last question. This is in fact the one I can find. This is supposed to be the newest one back in 2003 AB. Okay, so which is about like 15 years ago. I don't think they have released any other AP questions later than 2003 for the multiple choice questions. But anyway, right here we're given that what is the slope of the line tangent to the curve, which is given right here, and at the point 3, 2. So once again, we'll just differentiate this. Right here, I will just put down the dx, and we just have to do it carefully. Don't make the mistake that I did like earlier. I made 2 mistakes, right? So that wasn't good. And on the test, I wouldn't have any subscribers to back me up, right? So you have to be on your own and then do the questions carefully. Anyway, this right here, derivative of 3y squared, bring the 2 to the front, and then minus 1, we get 3y. Sorry, I make a mistake. 2 times 3 is 6. And then the y. And then differentiate the y, because y is a function of x. So we get dy dx. So that's it for the first part. Now for the next, bring the 2 to the front, and we just have minus 4x, and then 2 minus 1 is 1. So this is what we have. And this is equal to derivative of 6 is 0. And then right here, we have to do the product rule again. Let me break this down as negative 2x as the first function, and then y as the second function. So product rule says I will keep the first function, negative 2x, and then I will differentiate the second, which is the derivative of y, and that's dy dx. And then I will add the second function, which is y, and then I'll multiply by the derivative of the first. Derivative of negative 2x is negative 2. So this is what we have. And right here, you are given x and y already, and this is actually going to be a nice number. So you can actually just plug in the values if you like. Up to you, but let me just isolate the dy dx in case if the question is asking you to just get the dy dx by itself. Anyway, I will move this to the other side, okay? And this will have the dy dx. I will factor the dy dx out, put that at the end, just like how I did earlier. So I will have parentheses, 6y, bring this to the other side, becomes plus 2x, and then put both of the dy dx at the end of the parentheses right here. And this is equal to, bring this to the other side. Let me write this down first because this is positive 4x. This right here is minus 2y. And once again, I'm not going to reduce or simplify, factor anything out, because in the end, I'm just going to get the answer anyway. I'm going to divide this on both sides, and that we see that dy dx equals to 4x minus 2y over 6y plus 2x. And then now have time to just spend some time to plug in numbers. Don't make careless mistakes. That's all. 2 times 2 like this over 6 is right here, and y is 2. And then plus 2 times x is 3. Like that. And then just seriously work this out. This is going to be 12 minus 4, which is 8, over this is 12 plus 6 is 18. And then divide both sides, divide top and bottom, reduce the fraction, whichever the way that you want. 4 over 9 for the answer. Yeah, I know. We can just plug in the values. Yeah. That's pretty much it. B is 4/9. Okay. I think I might be able to, but not anytime soon, so I don't know. Yeah. Hello for the people who just like gone to that live stream. This is what I did today with everyone. We have the implicit differentiations and we did 5 questions. So let me just show you guys this real quick. And if you guys want to do these questions on your own, the file is in the description. Okay, and you guys can watch the video that's going to come up, which is the record of this live stream later, and you guys can watch the solution for that. Okay, so I will try to do about like 5 questions each every time if I do a stream, and they will be for AP questions. Okay. And I will do more for you guys, maybe Monday or so. But as I said, I would like to just keep the live stream for like 30 minutes or so. And this is almost time, okay? And later on, I will do more things with live stream. But I think as of now, I want to prepare my viewers for the AP calculus exams, okay? And you guys can go check out the link in the description. I will have the videos and the problems over there, and you guys can try those questions on your own first and things like that. That's pretty good, right? 40% got a 5 on BC last year. That's pretty good. Okay, thank you guys so much for watching. Thank you guys so much for watching. And then later on, yeah, if you guys know who are preparing for the AP questions, AP test, I would really appreciate that if you guys tell them about my channel and then my live streams. And this is, I think I have a lot of fun whenever I'm doing live streams with my viewers because it's like we're doing math together and I can get instant interactions with you guys. So that's going to be wonderful. And tomorrow I'll be running the LA marathon. So yeah, I'm going to just stop the live stream right now. Okay. And I will be back soon for you guys for the live stream. And then as always, I will turn around and say bye to you guys. And then this is for the people who wanted to see my shoe. Okay. This is the royal blue ones. Still dead stock. I haven't put this on yet. Yeah. I've been wearing the bread ones, but yeah. Anyway, bye. And thank you guys so much for watching. Bye. This is the hoodie, by the way. This is the hoodie. Yeah. Anyway, bye.